Today, let us talk about solid angles. And already in the previous years, you already have learned, about angles in a plane. Those are known as plane angles. Now, when we come to solid angles, it is something like it's a three-dimensional concept. Now, when one line is inclined on another line at a point and makes an angle theta, this is known as plane angle. Already you know about it. Now, when we talk about solid angles, what is solid angle? Suppose I take a circle. Suppose I take a plane circle and let me take one point away from the circle in a different place, not on the circle but in a different place. And now what I am trying to do is I am trying to join all the points on the corner of the circle to that point. Can you imagine what shape you get? You get a shape something like a cone. Not a perfect regular cone, but you will get a cone. It will be perfectly regular cone when that point which you have taken is at the center, perpendicular and at the center. Yeah, or you can say that it is at the equatorial point. Now this cone which is formed by joining that point to each and every corner of the circle, here the concept of solid angle comes. Let us try to mm, let me try to explain with the help of some diagrams, right? So solid angle is the three-dimensional equivalent of an ordinary two-dimensional plane angle. Means the SI unit of solid angle is T radian, and if suppose this is a cone, not a regular cone, but it is a cone, and this is ds, this is some area, and this is a point P, from where we had joined all the corners of this circle. It's a three-dimensional concept. You have to imagine. Now this is from point P. I had drawn a normal here, right? A straight line piercing this circle at the center. Now this is r cap, and this is d omega, which is known as solid angle, and this is n cap is the direction of the this area. Direction of this area. This is an area vector. So area vector's direction, as we had discussed earlier, area vector's direction will always be perpendicular to the surface, normal to the surface and outwards. So this will be outward. So this is the direction. Now this direction of the surface area, and this direction of the radius from means the point where all these the vertex where all these corners of the circle are joined, they are making certain angle. If it would have been a cone, a regular cone, then now also it is a cone only, but if it would have been a regular cone, then in that case r cap and n cap will be parallel or will be coinciding. The angle between r cap and n cap will be 0 degrees. Now here it is ds, and this angle is theta. Solid angle subtended by area element ds at the center O of a sphere of radius r is given by, this is the formula, d omega equal to ds by r square. Means area of the surface, this area by r square. What is r square? R square is the radius or the distance of the point from this point to the vertex here. So I can write omega means t radian will be integration of d omega for the whole surface, and it will be ds cos theta by r square, and if we solve this you will be getting 4 pi steradian. Now omega equal to 4 pi steradian means total how many steradians are there for a whole sphere. If I make this a sphere, complete sphere, this one, then what will be the total angle, or a total three-dimensional surface if I make it, what will be the total angle here, the solid angle? It will be how many steradians it will be? It will be 4 pi. This you have to keep it in mind. And where this the concept of solid angle, yeah, the concept of steradian, yeah, the concept or the formula omega equal to 4 pi steradian is used. It is used while deriving the Gauss theorem. That too Gauss theorem for irregular surfaces, not regular surface. For regular surface already we had derived. Now for irregular surfaces this formula is used, that is for solid angle. Now this formula, this theorem, Gauss theorem's derivation, already we have done this. You must have seen this, that vector E and vector ds both are on the same line, so angle between them is how much? 0 degree. So cos 0 degree becomes 1. Now today what we are trying to do is, today we are trying to prove again Gauss theorem for a closed surface of any shape. It is not a regular shape, but it is a closed surface and it is of any shape. Suppose I take this irregular surface here like this, and now I have to again prove Gauss theorem. You very well know what is Gauss theorem. It is surface integral of E dot ds equal to q by epsilon naught. Let us see how. This is plus q here. Let us keep it here, and let me take one cone here. As discussed earlier, when we are talking about solid angles. So let me take a small area here, and I am joining the corners of this area, each and every point, to the point q. This is the line joining the vertex. Let this be vector E, and this is r cap. R cap is the direction of E, electric field strength, and this is d omega. What is d omega? D omega is the solid angle, and this is normal to this surface, means n cap is the direction of the area vector. And what is the magnitude of area vector? It is ds, a small area. Now angle between this and this is how much? Theta. Angle between ds and r, yeah, e, sorry, or the unit vector r cap and n cap, the angle is theta. Now you can see here d phi means the total not total flux, but the flux for this surface area equal to E dot ds, that is 1 by 4 pi epsilon naught q by r square. From where this has come? This has come from E dot ds and cap, like Gauss theorem in the earlier case. Now d phi I can again rewrite this as 1 by 4 pi epsilon naught q by q ds by r square r cap in dot n cap. It's a dot product. So you already very well know r cap dot n cap equal to 1 into 1 cos theta. So only what will be remaining? Cos theta only will be remaining, because it is not 0. So in the earlier case for a regular shapes, what was cos theta? Cos theta was 1, because theta was 0. Now here theta is not 0, it is some certain angle, so it will be cos theta. Therefore d phi equal to q by 4 pi epsilon naught ds cos theta by r square, or ds cos theta by r square. You already know what is that. It is the solid angle. It is a solid angle. So for the whole sphere, if you make this a whole sphere like this, so this will be ds cos phi by r square will be how much? It will be d omega. That will be what? It will be 4 pi, because this value is equal to how much? This is equal to d omega, this is equal to d omega, and if you integrate d omega, so what will you get? You will get the whole sphere, and that whole sphere ka in steradians, what is the value? The value is 4 pi, I discussed earlier. Now 4 pi will cancel out, and you'll be getting q by epsilon naught. So this is the proof of Gauss theorem for a closed surface at any shape. Try to note it down. This is very important, because this part, when you talk about this part, this is very important, and you have to take care of this formula.